Hello, everyone. Welcome back to Forensic Science, our introduction college chemistry course. Now we are covering Chapter 10 Matter, Light, and Glass Examination. Physical and chemical properties. The forensic scientist must constantly determine those properties that impart distinguishing characteristics to matter, giving it a unique identity. Physical properties such as weight, volume, color, boiling point, and melting point describe a substance without reference to any other substance. A chemical property describes the behavior of a substance when it reacts or combines with another substance. Elements are matter is anything that has mass and occupies space. An element is the simplest substance known and provides the building block for which all matter is composed of. As far as forensic science is concerned, all of the elements are listed by name and symbol in the periodic table, usually represented in some way, shape, or form, like what's on the chart here, going by groups 1 through 18, or 1A, 2A, 3A through 8A, and the B blocks as well. And periods are going to be the vertical rows 1 through 7, where the lanthanide series is actually part of period 6, and actinide series are part of period 7. Compounds, those are two or more elements which combine to form a compound. A compound is a pure substance composed of one or more elements. An atom is the basic particle of an element. A molecule is the smallest unit of a compound. In reality, compounds are made of more than one element. Matter, phases of matter. Matter can be classified according to the physical form it takes, such as solids, which have a definitive, well-defined shape and volume, liquid, which has a defined volume but can take up the shape of any container it's placed in, and the phase of matter in the gas or vapor state, which does not have a defined shape nor defined volume. Substances can change from one phase to another without forming a new chemical species. Matter simply being changed from one physical state to another. Whenever a situation exists in which a substance can be distinguished by a visible boundary, different phases exist. According to the measurement system, scientists throughout the world use the metric system of measurement. The metric system has basic units of measurement for length, mass, and volume, which are meters, grams, and liters, respectively. Common prefixes used in the metric system indicate sections of those base units. They could be deci, centi, milli, micro, nano, or if we're talking about larger than the base units, kilo and mega, such as a kilometer is larger than a meter, a milliliter is smaller than a liter. Volume equivalencies in the metric system. What we have here is essentially 1 cubic centimeter is equivalent to 1 milliliter. 1,000 milliliters or 1,000 cubic centimeters is equivalent to 1 liter of volume. Comparison of the metric and English systems of length of measurement. 2.54 centimeters is equivalent to 1 inch on the imperial customary system. Important physical properties. Temperature is a measure of heat, intensity, or the hotness or lack of hotness, aka coldness, of a substance. In science, most commonly used temperature scale is Celsius. The scale is derived by assigning the freezing point of water a value of 0 degrees and its boiling point a value of 100 degrees. There was an interesting description between biology, chemistry, and physics about Fahrenheit, Celsius, and Kelvin. Uh, oh, yeah, Fahrenheit is good for biological scale, Celsius is good for the scale of water, and Kelvin is good for absolute zero. Essentially, 100 Fahrenheit is how much we can stay alive. 100 Celsius is how much water can stay a liquid before boiling. And, well, 0 Kelvin is the theoretical lowest temperature can actually get to, though not necessarily ever reach it. Comparison of the Celsius and Fahrenheit temperature scales. An interesting fact is, I believe it's negative 40 degrees is equivalent on the Celsius and Fahrenheit scale. They both are, when you say negative 40, you don't need to emphasize Celsius or Fahrenheit because they're actually at the same point. But 0 degrees Celsius is at the 32-degree point for Fahrenheit. And yes, important physical properties. Weight is a force which with which gravity attracts a body. So your weight is the gravitational force the you exert on the Earth. Mass refers to the amount of matter an object contains, independent of gravity. The mass of an object is determined by comparison to the known mass of standard objects. The measurement of mass, we have some unknown mass, and then we compare it to weights of known mass. And once they balance each other out, we then know the mass of the unknown. Sample. Density is defined as the mass per unit volume, or D equals M over V. That should actually be lowercase m over V, usually represented as grams per milliliter, or grams per cubic centimeter, or kilograms per liter. Density is an intensive property of matter, meaning it remains the same regardless of the sample size. If you have 500 milliliters of water, the density will still be the same 1 gram per milliliter as if you had 25 grams of water. The amount does not change the density of a substance. It's unique to the identity of that substance. It's considered a characteristic property of a substance and is used as an aid in identification. This figure is a simple procedure for determining the density of a solid, which is first to measure its mass on a scale and then measure its volume by knowing the volume of water it displaces when it falls into a container of known volume. You can think of density as mass divided by the change in volume after and before you place an object in a volume. If it goes from 40 milliliters to 50 milliliters, then 50 minus 40 is 10 milliliters. And taking 75 grams in the numerator divided by the volume, displaced is 7.5 grams per milliliter as the density of that substance. Refractive index. Light waves travel in air at a constant velocity until they penetrate another medium, such as glass or water, at which point they are suddenly slowed, causing the rays to bend. The bending of light waves because of a change in velocity is called refraction. Refractive index is the ratio of the velocity of light in a vacuum to that in the medium under examination. Light is refracted when it travels obliquely from one medium to another, for example, from air to water, water to oil, air to kerosene. Light has the potential to refract or change its angle of travel when it travels from one medium to another. Refractive light method. Crystalline solids have definite geometric forms because of the orderly arrangement of their atoms. These, these solids refract a beam of light in two different light ray components. This results in double refraction. Bifringement is the numerical difference between these two refractive indices. Not all solids are crystalline in nature. For example, glass has a random arrangement of atoms to form an amorphous or non-crystalline solid. For example, at 25 degrees Celsius, the refractive index of water is 1.33. This means that light travels 1.333 times faster in vacuum or roughly in air than it does in water itself. Light density refractive index is an intensive property that will serve to characterize a particular substance. Theory of light. Two models describe the behavior of light. Light is described as a continuous wave. Light is depicted as a stream of discrete energy particles. When light passes through a prism, it is dispersed into a continuous spectrum of colors. Representation of the dispersion of light by a glass prism. Light going through a slit so that only a specific wavelength of light, or so that white light and all its wavelengths can approach a prism, which refracts from one end and then refracts at the other end to become the different known colors of light, splitting into their different wavelengths from red, orange, yellow, green, blue, and violet. Visible light ranges in color from red to violet in the electromagnetic spectrum. Waves are described in terms such as wavelength, which is the distance between two consecutive crests, or consecutive troughs. Think of a wave as moving up and down. The crests are the top points, and the troughs are the valleys or the low points. Frequency is the number of crests or troughs passing at a given point, given unit in time, or how many times that wave moves up and down, oscillates per second, which per second is called a hertz. So what we have here is from one crest to another. That distance is the wavelength lambda, which is the same as from one trough to another. Lambda being the Greek letter used for wavelength. And the number of times this makes a complete cycle up to down, or the number of times it goes one complete cycle, however many times it does that in 1 second, that's the number of times, that's the number of hertz, or the frequency F or V, depending on what letter is being used in your particular system. Frequency and wavelength are inversely proportional to one another. As frequency increases, the wavelength gets shorter. As the wavelength gets longer, the frequency is lower. The electromagnetic spectrum is the entire range of radiation or light energy from the most energetic cosmic rays, high energy, high frequency, to the least energetic radio waves, low energy, high wavelength. Visible light is only a small part of the electromagnetic spectrum, where more energetic light is the ultraviolet and beyond, less energetic light is the infrared and below. As electromagnetic radiation moves through space, its behavior can be described as that of a continuous wave. However, once radiation is absorbed by a substance, it is best described as discrete particles of light known as photons. If you've ever heard of the wave particle duality of light, in reality, there are some materials that look like waves, there are some materials that look like particles, and Light is this third substance that looks like a wave and a particle, depending on what side of it we're trying to look at, its particle properties or its wave properties, but has both. The electromagnetic spectrum represented as a wave. The waves of light that have shorter wavelengths have higher frequency and higher energy. The wavelengths of light that are longer have lower frequency and lower energy, so less dangerous. We can use infrared radiation to heat stuff up, or microwave and radio waves, and ultraviolet light, X-rays and gamma rays can cause damage to our DNA. The visible light spectrum is just a very small portion, and some animals can see actually ultraviolet light, so they have their colors in that region, and some animals see in the infrared region, which means that they see the colors, but it's in their infrared region, whereas we see light in that little section that we call our version of visible light, where we see color. Glass composition. Glass is a hard, brittle substance that is composed of silicon oxides, sand, mixed with various metal oxides, sodium carbonate or soda. The chemical soda, not the drink, is normally added to sand to lower its melting point. Calcium carbonate, lime, is also added to sand mix to prevent the glass from dissolving in water. Forensic analysis usually examines soda lime used to manufacture most window and bottle glass. When molten glass is cooled on a bath of molten tin, it creates a type of glass called float glass, a type typically used for windows. Another type of glass is known as tempered glass. It is stronger than normal glass due to rapid heating and cooling of the glass surfaces. Laminated glass, found in car windshields, has a layer of plastic between two pieces of ordinary window glass, which helps it shatter without breaking into many pieces that can cause injury upon breaking. Glass fragments. A glass comparison is defined on the need to find and measure those properties that will associate one glass fragment with another while minimizing and eliminating other sources of that glass. To compare glass fragments, a forensic scientist evaluates two important properties: the density of the glass, the density, and the refractive index of that glass. The floating method. The flotation method is a precise and rapid method for comparing glass densities. In the flotation method, a glass particle is immersed in a liquid. The density of the liquid is carefully adjusted by the addition of small amounts of an appropriate liquid until the glass chip remains suspended in the liquid medium. At this point, the glass will have the same density as the liquid medium and can be compared to other relevant pieces of glass, which will remain suspended, sink, or float. Float if it's less dense than the liquid medium, or sink if it's more dense. The glass immersion method. The immersion method is best used to determine a glass fragment refractive index. The bending of light wave because of a change in its speed is called refraction. The ratio of the velocity of light in a vacuum to its speed in any medium determines the refractive index of that medium. The method involves immersing a glass particle in a liquid medium whose refractive index is varied until it is equal to that of the glass particle. The Becca line is a bright halo near the border of a particle that is immersed in a liquid of a different refractive index. At this point, the match point, the Beck line disappears, and minimum contrast between liquid and particle is observed. Analyzing cracks. The penetration of window glass by a projectile, whether it is a bullet or a stone, produces cracks which radiate outward, radial fractures, and encircle the hole, concentric fractures. By analyzing the radial and concentric fracture patterns in glass, the forensic scientist can determine the direction of impact. Production of radial and concentric fractures in glass. Radial cracks are formed first, commencing around the side of the glass opposite of the destructive force. That is on the left side. On the right side, concentric cracks occur afterward, starting at the same side as the force was applied. Analyzing cracks. A high velocity projectile, such as a bullet, often leaves a hole that is wider at the exit site. The direction of impact can also be accomplished by applying the 3R rule. Radial cracks form a right angle on the reverse side of the force. Radial rights reverse. I'm not sure who came up with that, but I hope they're proud of themselves. The sequence of impacts when there have been successive penetrations of glass is frequently possible to determine because a fracture always terminates at an existing line or fracture. Two bullet holes in a piece of glass. The left hole preceded the right hole. Collection of glass. If even the remotest possibility exists that glass fragments may be pieced together, every effort must be made to collect all the glass found. When an individual fit is thought improbable, the evidence collector must submit all glass evidence found in the possession of the suspect along with a representative sample of broken glass remaining at the crime scene. The glass fragments should be packaged in solid containers to avoid further breakage. If the suspect's shoes and or clothing are to be examined for the presence of glass fragments, they should be individually wrapped in paper and transmitted to the laboratory. In any case, just around the 23-minute mark. As always, likes and subscribes are not necessary, but they do make me laugh whenever I see them. They are kind of cute and, well, fun. In any case, pleasure to have you all. Look forward to the next video, and peace.